All right, welcome back, guys. We have another question from chapter 4 of Beer Johnston textbook, and we had these two links A, B, and DE that are connected by a bell rank as shown. We know that the tension in the link AB is 720 Newton. In the A part, we need to find the tension in the link DE, and we know the link DE is in tension from the question, and in the B part we need to find the reaction at C, which is a pin. So as always, we're going to start with the free body diagram, and from the question let's start with the DE since it says it's in tension. So this link will be in tension, which means the force at point D has to be in the opposite direction. So let's call this FDE. So based on the Newton law, this will be the force that is applying at the point D has to be opposite of the member. So that's why it's downward. And we have, so same reason for link AB, we know that also the link AB is in tension. So same, this will be in this direction. And that's the force that the link AB is applying to BCD, which means the force at BCD has to be the opposite direction. Let's call this FAB. And we also have the pin at point C, which we need to find the reaction. And since it's a pin, we have both X and Y component. And we're going to go with our equilibrium equation. Sum of all forces equals 0 and sum of all moments. We'll see that we have the most unknowns at point C, so we're going to start with our moment to cancel out all the two unknowns that we have at point C. Counterclockwise positive as always, and we have the moment of FAB, which is counterclockwise, so we have a positive FAB times, and we have to figure out the distance, which is what I'm showing in here. So we have this right triangle here that we know this part is 6 and this part is 8. That means this will be 10 based on the Pythagorean theorem. So we know the distance will be, so this will be 80, this is 60, and this will be 100 millimeter. So we'll have times 100 here. And as long as we have all the distance vectors in the same unit, we don't need to be worried about the force unit. And the other one is the moment of the FDE, which is a clockwise moment. So we have negative sign, and the distance will be what we have from here to here. So we'll have another right triangle here. We know this side is 90, this side is 120. The distance that we are interested is the vertical distance to the line of the action of the force, which is this distance in here. We are using the 2D shortcut that we have for the moment. I'm gonna put the link in the description, you guys, if you wanna refresh your mind. So equals 0, and from here we can find the relation between FDE and FAB. And from the question we know that FAB is 720, so our FDE will be 5 divided by 6 times 720, and from here we can find our FDE, which is 600 Newton. We obviously didn't get any negative sign because we were sure about the direction of the force since it's mentioned that it's in tension. So that would be the answer for the A part of the question, which we needed to find the tension in link DE. And the next we can move on to our Fx and Fy. So let's do our sum of all forces in X direction. This will be our positive. We have Cx, and FDE is in Y direction, so there is no X component for FDE, but we have X component of FAB. Let's show it in here. So if we want to show our Fx and Fy component of FAB, so this will be our FABx, and this will be our FABy, and this was our force, which was FAB. And we already showed that the right triangle that we have in here, this side was 60, this will be 80, and we have 100 in here. And let's call this alpha here, And if that's alpha, this angle over here will be alpha 2. And we can use our trick that we talked in the previous videos too, that if we have two angles that each side are perpendicular to each other, so that would be the one of them, and the other one is these two. That means these two angles are the same. So if that's the case, if we want to find the fx, we can see that the fx component of fab will be sine of alpha, and we know from here that sine of alpha will be 60 divided by 100, or 0.6. So we'll have 0.6 times FAB, which we know is 720. So we can find this will be equal to 0, and from here we can find CX, which will be 432 Newton. And we can move on to our FY, and we have CY, and this time we will have the y component of FAB, which this time will be the cosine of alpha, or 80 divided by 100. So we have a negative sign, so 0.8, which is 80 divided by 100, and same FAB 720. We also have FDE, which is downward, and we know FDE is also 600. So will be equal to 0, and we only have one unknown in here, which is CY, and that would be 1176 Newton. So if we want to find the magnitude of reaction, we have square root of CX squared plus CY squared. So we have 432 squared plus 1176 squared, and this will give us 1253 Newton. And if we want to find the angle, so we did not get any negative sign for CX and CY, which shows our assumption at the beginning was correct. So if we call this angle alpha, we know the tangent of alpha will be CY divided by CX, and alpha would be tangent reverse of 1176 divided by 432, and here alpha will be 69.8 degrees. And if you want to show C, will be 253 Newton, and this would be our angle alpha, which was 69.8 degrees, and that would be the final answer for this question. Thanks for watching. You guys take care. I'll see you in the next video.